Hi! Welcome to Chapter 6.5. We're going to solve square root and other radicals. This is part A. So we just finished simplifying radicals. Now we're going to look at what happens if we throw in an equal sign. So a couple things that we need to know. Definitions. Radical symbol. What is the radical symbol? Well, we know that's that. Okay, what's the radicand? So we got the symbol. Okay, what's left from the part? Well, the radicand is that thing that's underneath the radical sign. So 2x plus 5. Okay, and then we know the index, which is 3. Okay, reciprocals. Reciprocals are two numbers that have products of, in other words, when you multiply them, you get 1. So what's the reciprocal of 3? You're right. Congratulations, it's 1/3. What's the reciprocal of -7/4? Yes, you're right. It's -4/7. So we're just flipping them. Okay, so 4 steps. When we solve radical equations, the 4 steps are: we first need to isolate the radical. Or if we have 2 radicals, one of them has to be isolated. Okay, meaning we cannot have a number being multiplied and we hopefully don't have anything added or subtracted. 2. Okay, we need to raise both sides of the equation by the index. So if the index is 3, like our example, we're going to raise it to the 3rd power. If it's a 2, we're going to raise it to the 2nd power. Okay, number 3, we then actually solve for the variable. Solve for x, solve for y, solve for z. And the last one thing about radicals is, if you remember domain, range, and so forth, well, the domain of the radicals, we need to plug our answers back into the original equation to see if it's correct. Okay, these are called extraneous solutions. If we get a solution, we plug it in and it's false. Okay, must check for extraneous solutions. So we need to solve the radical. Be sure to make sure you check for extraneous solutions. Alright, following the rules. Okay, isolate the radical. Well, at least on A, it is isolated. There's nothing being multiplied out here or added or subtracted. So it is isolated. It is equal to something. Okay, now we're going to raise both sides. Well, the index, if you remember, is 2. We're going to take it and we're going to raise that to the 2nd power. Whatever you do on one side, you need to do on the other side. Okay, when you square a square root, the root drops off, or basically you have 2x minus 3, so the x minus 3 is by itself, equals 1. Now we can solve for x, so let's add 3. Okay, x equals 4. Now we have to check for extraneous solutions. So we're going to take the 4, we're going to plug it back in to the original equation. Okay, so we write a little check. Okay, take the square root. So 4 minus 3 should be equal to 1. The square root of 1 is equal to 1. Our solution's correct. Okay, B. Okay, notice we have 2 radicals. Okay, so technically we have to isolate one of them. Well, the one on the left still has a 4, but the one on the right does not. It just has a 1. If you were to divide by 4, you just make the right side a fraction. Now it's a little bit more difficult, so we're okay. So the index, both indexes are 2 and 2. So we're going to raise that whole thing squared and raise that to the 2nd power 2. Okay. By doing that, we're squaring the 4, which gives us 16, and then the x comes out, which is x. X minus 5 comes out. Now we can solve for x. Subtract x, subtract x. We get 15x equals -5. Divide by 15, x equals -5/15. Please reduce. -1/3. Okay, we need to check. As soon as we plug it into this x, and we plug it into this x. So, checking system over here. Okay, we're going to get 4. And then we're going to take the square root of -1/3 equals -1/3 minus 5. Well, if you look right here, we cannot take a square root of a negative. Okay, so right there that tells us that our answer is no solution. Notice we have the cube root of x plus 4 equals the cube root of 3x minus 6. There isn't anything to simplify here, so at this time we're going to raise these to the index of 3. Raise them to the third power. Okay. Now, if you have 3 of the x plus 4s, they cancel or come out, so we just have x plus 4, and then set that equal to 3x minus 6. Let's subtract x's to the left. So, minus the 3x, minus 3x. Let's move the 4 to the right. We're going to get negative 2x equals negative 10. Divide by negative 2, x equals 5. Check. So let's drive this back up here, and we're going to take the cube root of 5 plus 4 should be equal to the cube root of 3 times 5 minus 6. Okay, this is the cube root of 9. Can't do anything with the cube root of 9. There's only 2 3's. And we get 15 minus 6, which is the cube root of 9. Those are equal. It checks out. This is true. It's okay. And now, if you notice, we have no radical on the left, just an x, and then we have a radical on the right, but we're adding 5. So this is where we have to, again, isolate the radical. So let's move the 5 to the left, subtract 5. Okay. We now have x minus 5 equals the square root of 3x minus 5. Okay. Now your radical is isolated. Raise it to the index, which is 2. So we're going to square both sides. Okay, this is where it gets interesting. Right side should hopefully be a little easier. Okay, that's just going to give us what's underneath. So 3x minus 5. You now have to multiply x minus 5 times x minus 5. That's going to give us x squared minus 10x plus 25. Okay, sit there, stare at it. What do you notice? You have a degree of 2. You have a quadratic. With quadratics, let's move everything to the left-hand side. X squared minus 13x plus 30 equals 0. Remember the 5 ways to solve quadratics? Stick with 1 or 2 of them. Hopefully try and factor first. If you have to do quadratic formula, do quadratic formula. Okay, this will factor 2. X minus 10 times x minus 3 equals 0. Then we need to figure out, well, what makes the left hand 0? So x minus 10 equals 0. X equals 10. X minus 3 equals 0. X equals 3. So we have 2 answers. That means we need to check twice. Go back to the original problem. So I'm going to try 10 first. 10 equals 5 plus the square root of 3 times 10 minus 5. So 10 should be equal to 5 plus 30 minus 5 is 25. 10 should equal 5 plus 5, which is true. Now check the 3. If we plug in 3 equals 5 plus the square root of 3 times 3 minus 5, we're going to get 3 equals 5 plus the square root of 9 minus 5 is 4. So we're going to get 3 should equal 5 plus 2. Does 3 equal 5 plus 2? Does 3 equal 7? No. So we have one extraneous value. Okay. So we're going to cross out the 3. The 10, x equals 10 is our answer. One actual solution, one extraneous solution. Okay. Go ahead, hit pause. I know this one's a doozy. I will give you a hint. Move the 2, add the 2 times radical 2x over to the right-hand side. Go. Welcome back. I'm just trying to check and see. So here's at least where I got to in the first part. The hard part is, if you notice, is trying to square that binomial. Okay, which gives us the 1 plus the 2 times the square root of 2x plus 2 times the square root of 2x plus 8x. Okay, so what I did is I combined like terms and we're left off here. Notice we still have a radical, so you need to go back to the original problem. We need to isolate the radical, okay, which it kind of is. So let's now raise it to the power of 2, which means we need to do the same thing over here again. Okay, if we square both sides, we're going to now get 36x squared minus 48x plus 16 equals 32x. Again, you have a quadratic. Move everything to one side. 36x squared minus 80x plus 16 equals 0. If you can factor out, great. We can factor out a 4. If you factor out a 4, you're left with 9x squared minus 20x plus 4 equals 0. If you notice, 4 will never equal 0. So I'm not worried about the 4. Okay, so if we can just concentrate on the 9x squared, we can factor that to 9x minus 2. X minus 2 equals 0. Therefore, x equals 2 ninths and x equals 2. So again, we have two answers. Okay. Check for extraneous. Go back to the original problem way at the top. Okay. Do that on your own, but you'll find out that hopefully 2 does not work. So the answer is x equals 2 ninths. 2 is extraneous. Shoo! Congratulations, that was a toughie. Oh yeah, don't forget. Do your best, forget the rest. Bye for now.
Just 'cause you're like you don't need a